Now let's try to find out whether any simple graph is possible with this given sequence or not. Now if this sequence is given, so one simple way is find out the sum of the degrees, and if you see that it is an odd number, you can rule out saying that no simple graph will be possible with that, right? So if you see this sum here, these two are odd degrees and there are even number of odd degrees, therefore definitely you cannot rule out saying that there is no graph. So since the sum is even, now what is the other procedure? Go with Havel-Hakimi procedure. Now Havel-Hakimi procedure works only for simple graphs, right? It is not for multi-graph, and from here on we are discussing only about simple graphs. Okay, so even the question is about find out whether a simple graph is possible with this sequence or not. Okay, so what does it mean? We don't have multi-edges and we don't have loops, right? So whenever you delete a vertex, so how does this procedure work? We are going to delete a vertex, and whenever you delete a vertex, we are going to decrement. If we are deleting this vertex, we have to decrement 6 vertices by 1. So why? Because we are assuming that this particular degree 6, this vertex got the degree 6 because it is adjacent to 6 edges, and therefore by deleting that vertex all these 6 edges are gone, which will affect the degrees of other 6 vertices. In case if this would have been a multi-graph with a loop, right, then the decrementing might not work, isn't it? Why? Because deleting a vertex might not affect the degrees of the other vertices, but here we are assuming that it is a simple graph, then only we can apply that Havel-Hakimi procedure. Therefore this works only for simple graphs, and also the question is about find out whether a simple graph is possible with this degree sequence or not. Okay, fine. Now you decrease the degrees of these 6 vertices. Now this one will become 5, 5, 5, 2, 2, 1 and then 2, right? So one more thing, initially when you have even sum of all degrees is even, then even after deleting my vertex you are going to get even degree only. Why? The reason is when you delete a vertex, either it is going to be a vertex with even degree, now which means you are going to decrease, see the total sum is even, right? Now when you delete a vertex, you are going to delete twice the degree of it, isn't it? Why? Because when you delete that vertex degree is gone, as well as we are deleting a number equivalent to that number, right? Therefore this is what is happening at every step. The total degree, if it is even, from that you are going to delete a even number, isn't it? In this case you had deleted 6 as well as 6, therefore from a even number you lost 12, therefore the resulting is also even number, right? Now in the second case, see one more thing, you should always keep it sorted, right? Keep it in the non-ascending order. So what you should do, 5, 5, 5, 2, 2, 2, 1. Okay, now when you are deleting 5, you have to reduce 5 vertices by 1. So what happens, this is an even number. From this even number you are decreasing 5 here and 5 here, which means 2 into some number. Therefore from even number you are deleting a even number. So if initial sum is even, then at every step you are going to get a sum of even. So you cannot discard or you cannot do anything with the degree sums in between also. If you cannot do anything here, you cannot use that anywhere in the middle, because always you are going to get the sum as even, right? Okay, now you have to decrease all this, so which means 4, 4, 1, 1, 1 and then 1. Now you delete this, now you have to decrease 4 vertices by 1, which means 3, 0, 0, 0 and 1. Now just sort it out, which means 3, 1, 0, 0, 0, right? So what does it mean? You have a graph in which one degree is having one vertex is having 3 degrees, 3 edges adjacent to it, so like this. Now one is having 3 adjacent to this, which means like this, but then there is only one vertex of degree 1. It is not possible, isn't it? See this. Now if you try to see this, one vertex is having degree 3 and only one vertex is there with degree 1. Now how could this vertex get a degree 3 if there is no edge which is contributed by 2 other vertices, right? Therefore such a simple graph is not possible, isn't it? Or if you want to go one step further, if you want to delete it, there are no three vertices from which we can delete a number 1. Got it? Therefore here you can stop and say that no simple graph is possible, but a multi-graph will be possible here, isn't it? But anyway we are not interested in that, so there is no simple graph possible with that, right? So you can stop there and say it. And now let's look at the next example. Here also if you see the degree sum, it is going to be, there are two vertices with odd degree, so we can say that the sum is even, so we cannot rule out the possibility of having a simple graph. Now let's apply Havel-Hakimi theorem. Now what does it mean? You have to delete one by one. I'll delete 7, then for the remaining 7, 1 2 3 4 1 2 3 4 5 6 7, okay, so for all 7 of them I have to delete 1, so which means I get 5 5 3 3 2 1 1. Now if I delete this next one, for all 5, 1 2 3 4 5, right, I have to delete 1, I have to decrease 1, so I get 4 2 2 1 0 1. Just sort it out. So 4 2 2 1 1 0. Now if I delete this, for next 4 I have to delete 1, which means 1 1 0 0 0, right? So here itself we can see that there are 2 vertices of degree 1, therefore this way, and there are 3 vertices of degree 0, therefore that is a graph, simple graph, right? Or if you want to delete this, then you are going to decrement this by 1, so 0 0 0 0. If you get all zeros, then it is easy to see that there is a graph with all zeros, right? So you can say that a simple graph exists for the second sequence, okay? For this sequence it doesn't exist, for that sequence it exists, okay, fine.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%. But all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.